Next speaker comes from the Hungarian Research Centre for Linguistics, and Mr. Tamás Váradi is director at this institute. The title of his presentation is Developing Hungarian Language Models in the Context of Global Trends. Tamás, please give your presentation.
I understand that I'm not talking to a bunch of techies. On the other hand, ever since ChatGPT came on the scene, you are expert of what to expect of it, and it needs no introduction. Therefore, you are already familiar with language models. Let me, for the sake of better time management, let me give away my points. I want to take time back to 2022 when ChatGPT appeared, and I want to argue that it really was a game changer for techies like us. I'm actually a director not of the whole center, but of an institute called Institute for Language Technologies and Applied Linguistics. So it was a game changer for people like us. It really took us completely by surprise, and it still keeps us puzzling about its capabilities. And now I want to argue that it completely changed the scene, the ecosystem that was developing, and we now have to rethink our objectives as developers of national language models, right? So first, let me very quickly introduce I'm sorry, I have to do it myself. Sorry. So this research center is a long-standing institution celebrating its 75th anniversary, the leading research center for linguistics. And within it, there is for the past 30 years, when corpus linguistics came on the scene, we have been part of it. We are curating the Hungarian national corpus, and we are one of the leading centers of Hungarian language technology. And in fact, even on a regional scale, we are playing a leading role by having coordinated several EU-funded projects, etc. And in the year 2020, when NLP, natural language processing, was already following this new trend of instead of statistical models, neural network models, machine language learning, etc. So we also switched to this new paradigm, and we have been working on this field ever since. In fact, I can proudly say that we are the only player in Hungary to produce Hungarian large language models, because we've got the three components that clinches the matter, namely technological knowledge, know-how, data, tons of them, and compute. We were very lucky in 2020 to acquire our own infrastructure. Okay, and let me now quickly, how come? Oh yeah, I'm sorry. Okay, let me First of all, excuse me for the Hungarian. Obviously, it's a rehash of a Hungarian presentation, but not entirely. It is tailor-made just for you, and most of it is in Hungarian. So it's the Puli family of language models. This is the brand that we developed, and here is the timeline. In 2022, we were proudly celebrating the birth of our very own, genuine, only Hungarian language model 2 weeks before ChatGPT appeared and completely stole the show from us. But never mind. So you may have heard that it's about billions of parameters, and actually for British speakers it's 1,000 million. So this is the American style that I'm following. So compared to the language model behind ChatGPT, obviously this is a baby model. So ChatGPT is built on GPT-3 with 175,000 million or billion parameters. Parameters are the weights in this neural net, a very technical term. And we were very proud that it was trained on Hungarian data only, mainly collected from a common source that is followed these days called Common Crawl, a US company which crawls the whole internet so that others won't have to do it themselves all the time. Next year, we developed a trilingual model, Hungarian, English, and Chinese, for several reasons. We realized that Hungarian-only models are only too little as a data set. I mean, 32 billion, this compares with the current Hungarian national corpus of 1 billion, but very carefully curated and annotated corpus. So it's large from the perspective of the past, but currently, again, it's not enough. And also, we decided to incorporate other languages for reasons that I will show. So it was altogether 200 billion tokens, the corpus, out of which the Hungarian component is 41 million. And we followed a practice that the three language corpora are roughly of equal size, something that we won't find with ChatGPT, as I'll show you later. And this is the composition of the Hungarian training data with its sources. Again, apologies for the Hungarian. It's the international news, RSS feeds, then the Hungarian national corpus, and also something from social media and the Hungarian Wikipedia, right? So this is... And the trilingual corpus, as you see, is roughly balanced by languages. And now, the latest model is taking Meta's open source Llama 2 model, roughly of the same size. And Llama 2, as is now quite common, I will show you, already includes a sizable Hungarian or other language components. It altogether is trained on a corpus, a multilingual corpus amounting to 10 billion words, and we further trained this with Hungarian corpus of 8 billion, focusing on long documents, so that the assumption was that documents beyond a size are somehow curated, less hectic, less noisy components. Okay, and then there are new models which are called instruct following models. ChatGPT surprised the world by tuning GPT-3, which had already appeared 2 years before, but only was known by the community, language technologists community. So the one hat trick ChatGPT did was tune the model to users' expectations. This is the general problem of alignment. Aligning the output of the model, basically what it should be talking about, and so aligning it to the user's needs and requirements. If it is making a summary of text, so you know the usual things that you are using ChatGPT daily, I assume, translating stuff, summarizing stuff, answering questions, etc. Right? So this is the explosionary effect of ChatGPT, because formerly it was just a language model, and we will come back to this point. So now we have, out of this 3-language model, we tuned the model to take questions, right? To answer questions, and then we are following this with summaries, etc. So it is increasingly becoming more competent in serving your wishes, right? So it's no longer, I should tell you, it's no longer a language model that is working behind ChatGPT, and to what extent its capabilities are due to the language data it was trained on, or this instruct following procedure, which is called reinforcement learning with human feedback, right? This is what it is called. It is specially trained to follow, carry out instructions. Okay, so again, I show you the composition of the data set. And this is a very important point, that nowadays a large part of the capabilities of language models come from not the pre-trained part, but this further tuning, instruct tuning, right? This is what makes them, and this requires special data sets. And sometimes, I already warn you that sometimes famous data sets developed for English do not do not work for Hungarian, because the questions and these instructions that Hungarian users use obviously rely on Hungarian cultural knowledge, public, everyday knowledge of the Hungarian community of speakers, right? So it has to be not mechanically translating these data sets do not work. It has to be localized in the sense of conforming it to Hungarian culture and public speech. So how well do LLMs know Hungarian? Well, when ChatGPT appeared, look at the composition of the training corpus. It was already based pre-trained GPT-3 was pre-trained, not just for English, but look at the percentage ratio of languages. Hungarian is, well, in a fairly good position, but it's 0.065% within the overall composition. And what's more, this 0.65 amounts to 127 million, as against the 181 billion words. So hugely favoring, but not even the second, the French corpus, amounts to much, I would say. So just a quick comparison of our instruct following model, which was named Parancspuli. Parancs is command, right? So it's ready to carry out commands, and ChatGPT. There's no comparison. And then at that time, look at the data. We very proudly claimed, how come ChatGPT only knows, is trained on 127 million words? Surely our Puli model far outdoes that with the 41 billion Hungarian words. Now we have learned, since, to give a point away, we have learned better about this. But at that time we were very proud, very confident that surely this should be the way for us. Now, here is the language map of Llama 2 that I mentioned. Out of the 2 trillion words, the ratio is still, or even less, but look at the amount. So 0.3 already amounts to 600 million words. So we are roughly in this table. And there are other corpora, publicly available corpora now, like this MC4, M standing for multilingual. C4 is colossally cleaned common crawl corpus. That may be 5C already. Anyway, so it already has 39 billion tokens. Compare the 41 that we were so proud of a year ago or a year before. So there is another one basically of the same source, which already, after these cleaning steps that you see, already has 43 billion Hungarian words. And note that the 42 languages amount to 99.3, but the rest of the 167 languages amount to a mere less than 1%, just to show how unequal and how unjust the composition of these multilingual models, and how lucky we are that we actually feature. So, conclusion so far, the latest generation of multilingual global models know Hungarian pretty well. At least the training data is quite comparable to what we, specializing on Hungarian, could gather. So the models have seen enough data, and continued training that we did with Llama 2, already having a substantial amount of Hungarian, require much less data. So it was enough to further tune it for Hungarian with 8 billion models. On the other hand, instruct tuning require some smaller data sets, but more efforts to produce. Now, why bother you may ask, if these global models already have comparable data, have seen comparable data, and hence we perhaps wrongly assume comparable capabilities as genuinely trained Hungarian data, then why bother developing our own Hungarian? So here is the rationale that I submit to you for consideration. Number one is sovereignty from global tech players. They can turn off the service any time or set conditions that you can no longer meet, etc. Mind you, ChatGPT is not a language model, as you may find when you can select several language models. Language models are the engine. ChatGPT is a web service, and there is plenty around built on top of the capabilities of the language models itself. It's very difficult now to find out what is the contribution of OpenAI moderating the text, and what is the original genuine output of the language model that you choose. So we have no control over how it behaves, under what terms it is made available, etc. Then there is the issue of data security. There may be environments, there may be institutions where releasing your data to the cloud is absolutely out of the question. So the model must be employed to run on premises, on-prem models. And I've got some good news in that respect. Then there is the issue of linguistic competence, which I no longer emphasize that much, having stated that roughly they are, as regards, I would say, as regards general everyday linguistic capabilities, they are roughly in the same league, these global models produced by global partners. Then there is the issue of cultural alignment. Surely, if the data is only a fraction of the total corpus, then surely the cultural map or profile of the behavior of the model overall is heavily influenced by English or, well, American English or whatever culture, right? And this is what we find. And then there is the issue of responsible, explainable AI. Until we have a clear understanding or even control, not just understanding, but control of the training data, we cannot really take responsibility for the output, right? So definitely this argues for developing your own model, not to speak of the costs, which, by the way, may be tiny in terms of tokens, but it may amount to if you have an archive to process, obviously. Okay, so these are the points. And what are the new global trends promised in the title? Well, they are all very favorable. First of all, LLMs are becoming so competent that even smaller models may outsmart the big ones. So this is a very good development, speaking in favor of using our infrastructure. You don't really have to think of hundreds or thousands of parameters, etc. The other thing is open source models. And Meta, by releasing Llama, the Llama family, the latest of which was out a couple of weeks ago. By releasing the models with very favorable conditions, so even for commercial exploitation, allowing even for commercial exploitation, that really was gave a huge boost of developing. And then there is another point. These models can be not just smaller in size, but their size could be reduced by reducing the numbers that are used to represent the data. So instead of these vectors that the language is turned into are representing two bytes, 16 bits. You can reduce the number, making it coarser, to 8-bit, reducing the whole model by half, or even 4-bit. And just never mind what this represents. It actually various llama models, 70-bit. The full model is the blue one. And just compare the blue and the orange. And then you see some phenomena like, despite the fact that it became smaller by making it coarse, making the number representation coarser, they even outperform in some respects the full-scale model. Very good development, and this paves the way for LLMs coming to our smartphones. Well, it's already coming as far as Apple is concerned, but Samsung is not far behind either. So these quantized models help making LLMs enter your own comfort tool, I mean the smartphone. And it is not just the language model and this web service that you can build on it, but Llama, by releasing Llama Guard 3, is already providing developers with tools to build a safe environment in which the user input and the user output can be controlled. And this again is something that we definitely need, as I argued, because there is a lot that happens from the foundation models that happens between the prompt and the response. So this is what I refer to as OpenAI by working through different mediation layers, intervening between the model and your input or asking. Okay, a very important point is how to evaluate these models. As I already suggested, just the size of the corpus is not enough, because, much to our regret, it's not just the language capabilities of these models that matter, but how adroitly they serve your needs, how they follow your instructions. So quite a lot is now the expectation. So if we consider what makes LLM smart, Part of it is obviously the pre-training data, the attention mechanism, and the so-called objective function, find the next word. You may have heard that GPT models are trained to find the next word, and it will find it in a probabilistic way. So this is where the general linguistic competence comes from. But, as I said, there is a lot of instruct tuning with this reinforcement learning, with human feedback, or nowadays another alternative, direct preference optimization, that takes the care of alignment, the alignment problem. And then there is also a phenomena which is quite mysterious yet. So when you have a multilingual model, somehow the vector representation of these languages are of the same format, and somehow there is a cross-linguistic transfer operating. So you may ask ChatGPT in English or in Greek, and you may ask about a data set in Italian, and the answer will come out. I have 5 minutes. Okay, fine. Right. So we developed benchmarks. I mean, following the plethora of benchmarks available in English, we developed a set of benchmarks that are developed mostly for linguistic tasks. And our Lumix model does relatively well in zero shot, meaning just you shot a question and then expect the answer, or in several shots. But we decided that it's not enough, not relevant enough to apply the benchmarks that were developed of the previous generation of language models. For generative language models like ChatGPT, we need benchmarks to measure the famous hallucination problem, how relevant the answer, how good the summary is, what bias it shows how truthful the language, etc. So we are currently working on this, and here are these again the quantized models. I will just skip them and rather show this, which compares the big models and our Lumix models. So if you follow the red line, you see that in some tasks, even our Lumix model does quite well on these instruct following task. Okay, and so on the whole, the latest Lumix model, obviously a modest achievement, but still in the league, I would say. Overall conclusions. So the ecosystem has changed, and this requires that the objectives of Hungarian model development must be also reviewed, so that all the points that I mentioned among the rationale for national language development still apply, perhaps with the general language competence, but pre-training from scratch is obviously not viable. We cannot scale up the data on our mother tongue at all. Multimodal models are robust anyway for the phenomenal cross-lingual transfer, And nowadays, focus is more on alignment than general linguistic capabilities, which, as I said, can be done with smaller data sets, but require more efforts to produce. Therefore, however proud we are of having this amount of pre-training corpus, it is becoming less important in favor or as against these instruct tuning. And then there is a new goal, bringing LLMs to local devices. There are technologies that make LLMs more useful and relevant, but these are pretty technological issues. And quantized models, as I showed, promise to allow you to use LLMs directly running on your phone. And so, obviously, LLMs becoming more accessible and adaptable locally. And this is the good news that I'm bringing to you. Thank you very much.